It's part of our culture, President's Day.
Oh, MLK Day. Sorry, President's Day is February.
I was like, wait, that's in January?
Yeah.
We actually celebrate that?
What? President's Day?
MLK.
Oh.
I didn't even think. I didn't know why.
President's Day included.
Yeah, I don't know. Good afternoon. It is January 14th, 2020. So we have a review on Friday. So there's just more material today, Wednesday, and Thursday, and then it's a review, and then pass. So moving right along, which is good. And then we have chapter 6. And then we will start trig, which is exciting.
Triangles.
Yes, it is triangle.
No.
Is it hard?
That's literally all.
It's a different flip from algebra, but I teach it the kindergarten way instead of the advanced high school way.
I mean, it is triangles, right?
It is triangles. Triangles and circles. Yeah. Triangles rotated in circles.
How long are we gonna do?
Well, I'm giving us like 45 days.
Okay, so like a month.
Yeah, you don't actually need a ton for calculus. So I teach basically the stuff you really need. You get to go, if you choose, you may go straight to calculus.
Wait, do we get 2 credits at least for this one?
No, because you get a math credit for calculus, so it doesn't. And you get IP credit, which is like $6,000 if you pass the test.
I don't feel like sitting in this room for 6 hours taking
Oh,
For AP Cal, yeah, it's worth it. For $80 for the AP test and to get AP credit, and then not have to take it in college, it's like $6,000. Teaching it, yeah. I actually signed up for the AP Institute.
We had to teach AP calculus.
Yeah.
I don't think we learn any other way. It's really same way I'll never take AP water.
Having a good teacher is important. So here we go. Today should be pretty fast. So let's do this thingy. We're going to start today graphing log functions. And again, you guys have calculators that do graphing, so we aren't spending a ton of time graphing. But again, the idea is that you should know the basic shape. And so we're graphing log functions today and doing a tiny bit more solving. And when I graph log functions, I use these 2 properties to help me graph. Okay, and this first property, log base b of 1 equals 0. Why? B to the 0 equals 1. Because if you give it a swirly, it makes perfect sense, right? Okay, and log base b of b equals 1. Why? Because b to the 1 equals b. Yes, okay. Because if you give it a swirly, it makes perfect sense. Now, with these 2 properties, they're going to be super helpful for graphing. And we're going to graph, here is our sort of standard form for a log function. Y equals a times log base b of x minus h plus k. This is our standard form that we're going to be graphing using a log function. And again, we've graphed with h and k before. What does the h do? Yeah, it moves it sideways in the x direction, so it's left or right shift. And then what does the k do? Yeah, up and down shifting. And what we're going to do to start is basically look at the base graph here, which is everything to the x. And we're going to do a small XY chart for that base graph. Get some real easy points and then shift Shift. I put shift and left together. Shift, left, right, up and down. Okay. All right. So A is a stretch or shrink. We don't have too many of those today. So, what else? Oh, a few other things here. So a log function has a vertical asymptote. And that vertical asymptote, because vertical is x equals, it comes from whatever is inside with the x function. So whatever that x equals h happens to be, that's good information right there. So you can always get that vertical asymptote from whatever's inside with x. Okay, solving for x. All right, so let's, oh, I skipped the page, sorry. There we go. Example 1, graph the log function, identify the domain, range, and vertical asymptote. Graph the log function, identify domain, range, and vertical asymptote. Okay. So our first function, y equals log base 3 of x plus 2 minus 4. And so what we're going to do is we're going to start with just our base function, which is just log base 3 of x. Okay. With that base function, I'm going to go ahead and make a very small xy chart where we're using log base 3 of x equals y. And I'm going to use some very nice numbers for x. And the numbers that I want to use have stuff to do with the base of 3. Like powers of 3. Okay. So, well, we can do some easy things here. Like the first one is the value 1. So if I plug in 1 for x, log base 3 of 1 equals 0. Yeah, what?
3 to this.
3 to the 0 equals 1. Yeah, if you give it a swirly, that makes perfect sense, right? 3 to the 0 equals 1. Okay, good. My parents are picking up my kids from school. That's great. Okay. All right. So another thing, so we use 1 for the x value. 1 is always a good one to use. Okay. And then 3 is an excellent one to use because log base 3 of 3 equals 1.
27.
1. Why 1? 3 to the first equals 3, right? Because if you give it a swirly, it makes perfect sense. So these are the two values that you're going to use like every single time. 1 and whatever the base happens to be. Okay? There are other good numbers you could use as well, like any power of 3. So 9 would be an excellent choice as well. Log base 3 of 9. 3 to what power gives you 9? 3 squared gives you 9. Okay? So 27 would work, and 81, and some others. Okay, I could go that far. So it turns out, sorry, that was weird. We could also get some fractions in there, like you could use 1/3. But let's see. So 1, 0 is an ordered pair. Here's that 0.10. And 3, 1. 3, 1 is an ordered pair. So it turns out that the log function, and you can imagine 9 way out here too, is not growing very quickly. And then what happens in here, if I had chosen log base 3 of like 1/3. 3 to what power gives me 1/3? -1. Yeah, so 1/3 -1 is another point. Log base 3 of 1/9 equals -2. So that'd be 1/9 -2. So you can see what's happening. We're just getting closer and closer and closer and closer to the y-axis. And so it turns out that this log function has a vertical asymptote, normally at x equals 0. And it just gets really, really close. I lovingly call this the log ride. So exponential functions was a Superman ride. See the theme? Yes, I'm going to Disneyland in 5 months. So,
5 months in it.
yeah.
Wow.
Oh, yeah.
You can't go to Disneyland any other way.
And my husband already, like, I get the daily update. Do you want to hear the news today? And he's like, I'm like, okay. And he's like, lines were really awful today. Peter Pan was an hour and 42-minute wait. So, okay.
The best of fast passes.
We don't, because I really hate California Adventure. So we do one part today. New Year's Day is really good. Yeah, you wouldn't think it, but it's really, really good. Okay, sorry, I digress, but here we go. So this is the log ride, and why is the log ride? Because when you think about a log ride and you start the log ride, the first thing you do is you sit down in your little watercraft, and on every single log ride, what is the very first thing you have to do? Go up. Click, 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 right? Every single log ride, the first thing you do is just go up for a really long time. And then it's like, it's a small world after all, where you just sort of float around and not a whole lot happens, right? That's a log ride.
Until the drop.
Yeah, okay. Until the drop. Okay, but that's the one thing that, okay.
I think
But-
Splash Mountain's kind of better comparison.
Yeah.
You go up and you just kind of
You
float.
just kind of float around, exactly. And so that's sort of what I envision this is. It's like you go up, 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 and then it just sort of fizzles out after that. It doesn't do much. Okay, but this is it. So now we get to shift this log ride. What does x plus 2 do to this function? Left 2 and down 4. Very good. And so I'm going to take these 2 points here and just shift them left 2 and down 4. Left 1, 2, and down 1, 2, 3, 4. And I'm going to go left 2 and down 1, 2, 3, 4. And so the whole, before I draw that, what happens to this vertical asymptote if it gets shifted left 2? Yeah. So we have a vertical asymptote at x equals -2. And that vertical asymptote comes from solving the argument here. X plus 2 equals 0. If you solve for x, you get x equals -2. So we have a vertical asymptote here at x equals -2. And then the log ride, which goes up, 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 and it helps if you do that. Okay. With that graph in mind, what is the domain? -2 to infinity. Very good. How far left does it go? It stops right here at -2. Included or excluded? Excluded. Very good. What is the range? -infinity to +infinity. So everything has been flipped. This log function is the inverse of the exponential function, the Superman graph. So you'll notice the domain and the range have sort of swapped, and also what was a horizontal asymptote is now a vertical asymptote. So everything is inverted because they're inverse functions. All right, let's look at this one. This has a base of 3. Is this, and this function is an increasing function. What do you think is going to happen with this base of 1/4? Decreasing function, yeah. I led you right into that. Is this -3 on the inside or the outside of the function?
Outside.
Outside, very good. It's not with the x. All right. So here is my base graph. I'm going to do a little xy chart. Log base 1/4 of x equals my y value. So I want to figure out that corresponding y value. What should I plug in for x? 1. Log base 1/4 of 1 always equals 0. The log of 1 always equals 0. What's another good number to use for? 4 is a good number. There's another one, an easier one. 1/4. Whatever your base happens to be. 1 and the base for your x values. So log base 1/4 of 1/4 is always 1. Because if you give it a swirly, it makes perfect sense. So we have the point 1, 0, and we have 1/4, 1. And so you can see this is now a decreasing log, right? Which is wee, and then it slides really. And if you needed to check some other, values, other x values, you could. So any power of 4 would be good. All right, so then how is this shifted? What is this -3 doing? Well, what's the difference? Yeah. What's the difference between x -3 in parentheses and what's here? Yeah, this 3 goes left and right, but this one goes down. Okay. Down 3. This one goes right 3. So those parentheses are really important, whether it's inside the function or out. It affects the x if it's inside, otherwise it's the y. So we're going to count down 1, down 2, down 3, down 1, down 2, down 3. Does my vertical asymptote change? No. So it's right at 0, x equals 0, and then there is my graph. So our vertical asymptote is x equals 0. What's the domain? 0 to infinity. How far left and how far right the graph goes. And the range? Negative infinity to positive infinity. Forever down and forever up. Okay. So remember, domain is the x-axis, how far left and right on the x-axis, and range is the y-axis, how low and how high. All right, questions on graphing? All right. Last thing. Example 2, use the one-to-one property to solve the log equations. We did one of these yesterday. What is the one-to-one property?
They're the same on both sides.
Yeah.
We use the one-to-one property a lot.
Make two things.
Yeah, if x
Both
plus
sides
7 equals 5 plus 7, what's x?
5.
5.
Whoa.
Because if these things match, then these things should too, really by the property of equality, because that's what the equal sign means. So when we look here and we have log of 5x minus 7 equals log of 3x, if the logs match, then what must be true?
5x minus 7.
Yeah, then the arguments must match in order for those things to be equal. So let's see, that's going to give me a 2x equals 7 and divide by 2. So we get 7/2. All right, letter B here. Log base 5 of 7 minus 3x squared equals log base 5 of negative 2x squared minus 6x. So we have a log equal to a log. If the logs match, what must be true? Then the arguments must match. So these arguments must be the same. So 7 minus 3x squared must equal negative 2x squared minus 6x. This is linear. What is this one? Quadratic. How do you solve a quadratic?
Get them all on the same side.
Get them all on the same side equal to 0. Very good. I want to move this over here so that it turns to positive. So I'm going to move both of those over. So I'm going to add 3x squared, and I'm subtracting 7 so that I get positive x squared minus 6x minus 7. And then what?
Double bubble.
Double bubble. Factor. Whoa. All right, x times x is x squared. What times what is negative 7?
7, 1. Negative 1, 7, and 1.
Good. All right, which means x equals?
7.
And x equals? All right, one of these works and one of these.
7 works.
7 doesn't work. 7 doesn't work.
7 doesn't work.
7 does work. Does not.
No.
Wait.
It's half the room agrees. 7 minus 21.
Where did you get 21?
It's a little bit more than
147. 7
Yeah.
minus 147.
So
yeah. That's negative.
so you're plugging back in?
Yeah.
Okay, so if we take 7 and plug 7 back in, that is 7 minus a giant number. Yeah? Which is a negative result. Can I take the log of a negative result? No, I cannot. So 7 does not work. The negative 1 is totally fine because I'm going to plug it in. And you square that, it turns positive. So it's just 7 minus 3, which is 4. I'm going to check over here too. Log base 5 of negative 2, negative 1 squared minus 6 times negative 1. That becomes positive. So we have negative 2 plus 6, which is also a positive 4. And that is okay. So as long as the argument is positive, that is going to work just fine. And that has to do with the graph. So if you think about the graph, log base b of x, it has a vertical asymptote and it's everything to the right. This argument, whatever is with x, can't be in negative land. There's nothing there. All right, it's undefined. So we want that argument to be greater than 0. There you go. That's it. Do you have questions for me? All right. Can you pass out the worksheet? The worksheet.